So I'm going to talk a little bit about what is CI, what it is, what our challenges are, and just to give you a little background for the next couple days on what to think about. So, as John and Richard alluded to, the nature of research today is changing, where it's no longer a single researcher working in his lab doing his experiments and writing it up. It's groups of researchers across multiple institutions trying to solve big problems. And so cyber infrastructure is what enables them to work together as a group, even though they are spread across the globe. There's also a new driver for CI. The National Science Foundation has now required that every proposal have a data management plan included in there. And so a lot of that involves CI. And I think NSF is trying to kind of explore what this all means as well. How can CI be part of all your research and be part of the proposals that go into them? So you're going to see this concept of the data management plan evolve over time and to be more useful. So, we're focusing mostly on research with cyber infrastructure. That's where it got started. National Science Foundation kind of coined the phrase, and it's moved on to other agencies as well. But we're going to focus on research for the next couple of days and my talk. But we need to remember, too, that cyber infrastructure is moving into other areas. So teaching is changing so that it's using cyber infrastructure. You're seeing network-based multimedia resources that are coming into the classroom. There's real-time communications that are going on with the class, both in the class and asynchronously elsewhere. You're seeing cases where multiple locations can have the same class at the same time. Online classes, team teaching, all these things are allowing teaching to change in the way that it's presented. Cyber infrastructure is also in administration. I mean, we've all thought about administrative computing as the big cyber infrastructure thing there. But we're also seeing that some of the things that we're developing for research and for teaching are used in administration as well. For example, identity management. A lot of the universities are working on creating an identity management system that can be used in all aspects of the university so that you have a single login for all your access. Okay, so I want to go through an example of a researcher that's using CI to see about some of the different components that might be used. So Jane, a fictional researcher, is an environmental researcher working on global warming, big subject these days. She needs to do a lot of different things. She needs to collect data, store data, analyze it, do some simulations, do some visualization, and share her ideas with a group of researchers that she's working with. So let's look a little bit at what's under the CI hood. So we take a car analogy. Someday you'll be able to get into the car, tell it where you want to go, and it'll drive itself there. Well, we aren't really there yet. So you still need to know some things about that car. You need to know that it has an engine, it has brakes, fuel system, etc., so that you can operate it appropriately. Now, you don't need to know a whole lot of details on all those, but you need to know they exist and how they interrelate and things like that. So, kind of using the car analogy, let's look at what Jane uses in cyber infrastructure. Okay, so the first thing she wants to do is she's got some remote instrumentation out there. She wants to tell those instruments to start taking some data. So she wants to be able to send a command to the instrumentation and say, start collecting this particular data. Okay, that'd be a good thing, except for how does the instrumentation know it really is Jane that's asking for that? And so you need to have management with security and access in there. That goes into that identity management thing I just talked about. So the security and access controls will go and verify that, yes, this is actually Jane. the instrumentation will trust the security management when they say, yes, this is Jane, and she can tell you what to do. So it goes through that step, and then the instrumentation starts taking the data and starts figuring out what the environment really looks like. So now that we've started collecting some data, Jane wants it to transfer to some data storage. Now that could be anywhere in the world. So she wants to be able to tell the instrumentation, take all the data you collected and send it to this location, put it in in these files. Now the security management has to be in there again, because data set storage needs to know that Jane can say that. Then the instrumentation also needs to know that it's being coordinated. So security and access management ends up being in everything that activity that we do. So I'm not going to mention that anymore. Just assume that it's there. So Jane has this data flow that's going from the instrumentation being stored in the location. Next thing Jane wants to do is do some data analysis. So the computation starts coming into it. So the computation can take the data set, start crunching the numbers, and then put the results back into storage again. Now the computation in the data sets might not be in the same location, so you end up transferring the information back and forth. So Jane's now gotten some results from her analysis, but she wants to be able to understand it a little bit better. So that's where the display and visualization starts coming in, where she can see what's going on. So some of the results that have been stored can be sent to the display and visualization, and she can see her results. Okay, next she's got some idea of what's going on. She wants to create a model, and so she starts creating a simulation, and that's going to require the use of the data sets, the computation, the visualization, all so that she can see how her simulation is working. And so we're starting to see more components of cyber infrastructure added in here. Okay, she's got this idea on this great simulation. She wants to bounce the idea off with some of her colleagues. So you end up having a human support aspect in there. So she needs some collaboration tools so she can talk to her fellow researchers. She also might need some training on some particular aspects, so learning how to use some new tools. She needs to publish her results, put it out there so that others can look at it. And then she also might want to do some outreach to tell the K through 12 what she's learned about the environment so that they can experience that as well. Okay, and then finally, Jane wants to go after a new grant to explore her ideas further. And so policy and funding comes into the picture. Now, you might not think that is necessarily a part of cyber infrastructure, and you can draw your circle around whatever parts you think are correct. But policy and funding does have a major effect on cyber infrastructure. So you end up having to deal with that. So there you can see one picture of some of the components of cyber infrastructure. And there's still one thing that's missing on there, and that's how do you connect all these together, and that's the network. So you've got the network that goes and connects all these together and allows the system to work no matter where the resources are located. So there's the components, there's also the people. So here's a diagram that kind of shows what different people are involved. And that's kind of what the CI Days is about, is all these people have to come together to be able to make it work. So you've got the researchers, you've got the campus IT, those security people I was talking about, the network providers, people that provide computing through supercomputer sites, grid organizations. You have the discipline groups that are working on their own research. A lot of times they end up having their own CI support within them. You have the collection organizations. So what we're seeing is libraries are getting a lot more involved. Libraries are starting to figure out what they're doing in the digital age. It used to be that somebody would do their research, they'd write their thesis, it'd go get printed, it'd get stuck in the library. Well, there's a lot more to it now that there's large data sets, there's software that's involved, and the librarians are starting to think about, well, how do we keep all that stuff for posterity as well? So also the librarians are starting to think about the data you're collecting. A lot of times I've seen researchers where they want to create a data set, and so what format are they going to use? What schemas are they going to use? What kind of metadata is necessary? And they say, well, we'll just make something up, which is fine for their own project until they want to start sharing it with somebody else. And then it becomes problematic. So I've been telling researchers, go talk to your librarians ahead of time to get some help on that, and then maybe it'll be easier to share in the future. So collections organizations are important. And policy, leadership, funding, all those that keep keep it all rolling. So as you're going through your CI days today, try and talk to some of the people that maybe you wouldn't talk to otherwise. I mean, that's kind of the point here, is that each of you have a role to play. And if you can express that to others, then you start figuring out how to make the whole CI system work a little better. Okay, you could take the picture of the functions and change it around to meet your own needs. For example, you can change it around for instructional viewpoint. So you have an instructor, you got students, but you still have a lot of the other components, so the human support and the other technologies. So cyber infrastructure can be looked at in many ways, and each of you have to look at it in your own. Okay, a little bit about some of the major components. If you want to look at the networks, I kind of just threw that in at the end because most of the time you don't want to have to worry about the network. It's something you just want to be there. But it's good to understand that when you talk about the network, it's not just one network. It's actually many networks connected together. So if you think about the flow going from your desktop to a colleague at another university, it goes across your campus network, it'll go across a regional network, there's national backbones that connect all the regional networks together, and then likewise going down the other side you have regional networks, campus networks, and then the other end. It's also tied into international networks. So that all these networks have to work together. And so when you start thinking about the network, it's not just a single entity, it's all these networks working together. And what you're going to experience will only be as strong as the weakest link in that whole chain. So understanding that all the people that are involved in your network experience is important. Okay, computational resources, there's a lot of ways to provide that as well. You can start out using your desktop or a lab computer, but then you might want to get a little bit more power. So you might have your own cluster, or there might be campus shared clusters or regional shared clusters. There's national centers to provide even more computing. Sometimes disciplines create their own resources. So in computing, there's a lot of ways to do it. One aspect we're hearing now is cloud computing. And so, is that a resource that you want to look at? You need to look at all these and figure out what is appropriate for your own needs. Likewise for storage. You might have your own storage. It might be a campus repository. National centers have storage. Distributed storage is something that's being looked at now, where the storage doesn't reside in one location, but multiple places across the country. And you don't have to necessarily worry about where it's being stored. The system itself will move data to where it's most convenient. So for example, if you had a data set that you wanted to pull that was across the country, the distributed storage system might say, okay, this is being accessed fairly often by you on your side of the country. Let's move a copy over so it's closer. So those kind of things are being looked at for storage resources. So pulling it all together, There are gateways or science gateways. The Hub Zero project was mentioned, and that's a big one where it tries to pull these resources together to make it easier for you as a researcher to be able to access all these resources without having to understand them in great detail. Being able to have common software helps too. If you have software that you want to use at different systems, if it's available on those different systems, that helps. The common data formats and schemas I talked about, I think it's an area that needs a lot of work. We still, if we want to start sharing information between disciplines, between research projects, we need to have a way that we know that that's going to be easily done. Then performance and monitoring tools. How do you get the most out of what's there? How do you know that you are getting what's possible? And so those kind of things are coming about now as well. So as I've gone around talking to various researchers, I've found that you can kind of look at it in two ways. There are those researchers that have really dug into the technologies. They've learned it. They've created their own resources where they build their own cluster and such, and they really get into it. And so those are the researchers that we've seen that have developed the cyber infrastructure environment so far. But there are also a lot of researchers that don't want to become CI experts. They want to focus on their own discipline, rightly so. And so they are finding that they need to use CI, but they need it to be as easy to use as possible. So how many of you out there would say that you've been the ones that have dug into CI and made it your own? You've become experts. There's a few. How many of you are waiting for CI to be easy enough so that you don't have to become experts? Seems to be a lot more. So also what we're finding is that those researchers that have dug into it and have learned it, it's becoming more and more complicated over time. And so, maybe it's not quite as much fun as it used to be. They would like it to be easier as well. So I think one of our goals is to make it easier to use for everybody. So is cyber infrastructure too hard? I mean, should you really have to worry about the network? I mean, today, when you're using a network, frankly, most of the time, it's not going to work at maximum performance the first time out on the box. And a lot of times you have to get a person in that knows what's going on or become an expert and do some tuning to find out where the weak point is, and then go and fix that. Are computers too hard to use? Well, one of the things that we see is that maybe you're starting to develop your research on something in your own lab, either your desktop or a small cluster or something in there. And then as you've developed your process, you want to move it into a larger sphere. So you want to use a larger cluster or a national center or something like that. But what you find is that when you go in and you want to move it, it requires some changes. The software is not quite right, or you have to do some recoding or things like that. That's not particularly easy either. Storage, where should the storage be? If you end up having it far away, sometimes that affects your performance. So you start thinking about the storage. So wouldn't you really have it so that you can just run the application and do the things that you want to do? So maybe that's one of the goals that we want to do for CI is to make it easier. Now, we've all been hearing about the cloud. Now, what is the cloud? Well, to me, it's somebody else takes care of your technology for you. So in some ways, for some of you old timers, remember when we had a mainframe and you had terminals that connected in the mainframe? Well, in some ways, that's kind of what we're going back to, is that somebody else takes care of the technology and you just access it. But there's things you need to think about as you're thinking about a cloud. I mean, a cloud can be provided by multiple different institutions. It can be the commercial sector. That's probably one of the big ones that we're seeing, is that what's being provided by Amazon and others as a computing resource. But there's also academic clouds that are being built. Now, but some of the things you want to worry about on the clouds: do you actually trust them? Your data is going to be sitting out there in their environment. What kind of privacy, what kind of protection are you getting for that? Can you rely on them? Will they be there when you need them? What happens if it doesn't really work out? It gets too expensive, or they don't have the capabilities you want, or they change their service in some way that it doesn't work for you. Do you have an alternative? Is it easy to go from where you are to that alternative? So those are things you need to think about as you're moving into thinking about the cloud. So in a lot of ways, advanced CI isn't being used by a lot of researchers. I think a lot of people are waiting for it to be easier. So why is that? Well, as I've been going around, I found two major reasons. One is that every time you want to use a new application, you have to learn a new interface, and that takes time. It's not much fun, and it's not easy. You think about, go back to the car analogy. What if you had a different user interface for every type of car? In other words, you had to go actually read the manual and figure out how to drive a car every time you got into a new car. I mean, the car rental agencies would be in big trouble. So wouldn't it be nice if you had a way to go into a new program and have a pretty good idea of how it was going to work? There was one CI days where I was in a room with a group of faculty, and I asked them, if you could have any user interface you wanted, what would it look like? And they scratched their head a little bit, and one guy says, well, it looked like an Excel spreadsheet. And yeah, Excel spreadsheet probably is not the greatest user interface in the world, but it's one that they know. And so what we really need is an interface that you can learn and you can build upon, so that what you learn from one application can be extended to the next. Yeah, there'll probably be some little changes, kind of like a car. You know, there's new features that are on cars that you might have to look at the manual to figure out how to use, but the basic functions are the same across multiple cars, multiple applications. The other issue I've been seeing of why people are having difficulty with CI is the performance and reliability. So as I mentioned, a lot of times you might require an expert to come in and get things working right for you. But then as soon as anything changes in the environment, all of a sudden it's not working again. So that ends up having a lot of people say, well, you know, I'm just going to go back to what works. So we really need to work on how to make it reliable, how to have it working at the maximum performance. Now, some of the issues why I think we're running into these problems is because you saw all the different components of cyber infrastructure. And they've all been developed independently and kind of just patched together. So there is no real system view of CI as a whole. So the network doesn't talk very well to the computers as far as understanding what the needs are. The computers don't necessarily talk that well to the applications. What we need is a system view where every part understands what is trying to be accomplished. And so that's an area of research that's going to be required. So in the meantime, you know, we have some tools out there that can help. Not as good as we would like, but they can do some of the testing and give you some clues on where the problems are. Security is another aspect on that, where security has been developed for each component independently, but there's no system view of security. So that a lot of times you end up with security on different components competing with each other, and so it doesn't work quite as well as you want. We need to have it so that performance and security are built into all components as a system, so they understand the entire application. Okay, so I want to close with my view of where we might be with CI in the future. So what I'd like to see is that computation and storage allows easy transition, so that you can do your development on the desktop. Move as your needs grow, you can move to maybe a campus resource, a regional center or national center easily, so that once you've developed your system, it can just move from one provider to another. I'd like to see data repositories and formats and locations that allow the ease of sharing. So, this is the real digital library, so that as researchers do their research, particularly in the environmental studies, if we're trying to understand the environment, if we need to have it so that these researchers create a contribution to the overall knowledge, and it can be accessed by others. We need tools that allow you to easily construct your application, so that you can, if you have a particular thing you want to accomplish, you can take components and kind of glue them together and create an application that you want without having to become an expert programmer. Then finally, we want to have collaboration tools so that people can work together as though they're working in the same room, even though they're spread across the world. And so if we can get those things working smoothly, then I think we've got a functional CI system. So I want to take a couple minutes to ask you, what are your biggest barriers you're seeing in cyber infrastructure? I mean, what is it that you would like to see happen in cyber infrastructure that would make it easier for you to use, make it more likely that you use? So, someone must have their favorite. Think about it as your pet peeve. What would you like to see fixed?
I'm probably more in the functional end of cyber infrastructure, but right here today I could say model cyber infrastructure and make some of the things available for us on a maybe Hub Zero environment. Specifically, I'd written down, I wanted to know from you, I wanted to have your CI vision slide so that I could take that and use it further.
Well, the slides will be online, I believe, afterwards, so. Did you want to start setting up while I was? David has a unique system he needs to set up here, so while we're continuing our talk, I'll let him do his thing. So what else would you like to see in cyber infrastructure that you don't currently have?
The biggest hurdle that we face, and I'm in healthcare engineering, is protected health information. And so the more and more we could get security across CI in a way that allows health information to be used by others would really be a plus.
Yeah, the HIPAA stuff makes it hard to implement. Other things?
I guess I would like to make sure that the humans are not overlooked in all of this. I think, you're only as strong as your weakest link. And in my mind, my ability as a researcher to get to the technology is directly dependent on having a person, that can make that bridge for me. So I'd like to see more humans.